Welcome to the 10th lab overview for an introduction to mathematics for finance. During this week's lab, we'll take a look at calculating purchase prices for coupon bonds, calculating premium and discount amounts in the purchase of a bond, and creating bond schedules. Bonds are often used by corporations or governments when they need a large sum of money for a long period of time. A bond is a written contract that the issuer, so the government or the corporation, sells to an investor called the holder of the bond, which promises to pay back a stated amount of money at some future date. If the government or the corporation sells what's called a coupon bond, this means that they'll pay interest or coupons throughout the term of the investment to the investor. Some notation. The face value F of the bond is the amount on which the issuer pays interest to the lender. The redemption value is the amount that's to be paid back by the issuer at the time of redemption or maturity. Take note that there's different types of bonds. You can have one that's called redeemable at par, and that's where the redemption value is equivalent to the face value. If the redemption value is greater than the face value, so C is greater than F, then the bond is said to be redeemable at a premium. And if the redemption value is less than the face value, then it's said to be redeemable at a discount. The coupon rate R is the rate per interest period at which the issuer pays interest to the holder of the bond. The yield rate I is the rate per interest period at which the investor would like to earn. The purchase price of the bond is the price paid by the holder to yield rate I. The coupon payments or interest payments that the investor receives throughout the term of the investment is calculated by F times R, the face value times the coupon rate. And lastly, N is the number of interest or coupon payment periods throughout the term of the bond. So let's suppose you were considering purchasing a bond and you wanted to calculate the purchase price to yield some rate I. There are two sets of payments that you would receive. The first set of payments is all the coupon payments throughout the term of the bond. So at the end of each period, you'd receive F times R for your coupons. Then the second payment that you would receive is at the maturity date, and that's the redemption value of the bond. So to calculate the purchase price yielding rate I, what you want to do is discount your coupon payments of FR dollars back to time 0, the time at which you purchased the bond, and that's just the discounted value of an annuity. Then you also want to discount the redemption value of the bond end periods using compound interest. And this is called the purchase price formula for your bond. Take note that there's also an alternative purchase price formula, and if you take a look at your lecture notes, it shows you how this formula is derived. Also, make sure that the periodic yield rate and the periodic coupon rate coincide with the coupon payment periods. For example, if your coupon payments are monthly and your rates are compounded semi-annually, find equivalent monthly rates. Suppose that there is a 3-year $10,000 bond redeemable at 105 and it paid monthly coupons at J12 equals 12%. How much would you be willing to pay for the bond if you wanted to yield J12 equals 15% on your investment? First, let's write down what's given. We know the face value of the bond is $10,000. The coupon rate is J12 equals 12%, so R is 0.12 divided by 12. As an investor, you want to earn J12 equals 15% on your investment, so that means I is 0.15 divided by 12. The number of coupon payments throughout the term of the investment is 36, since it's a 3-year bond and coupons are paid monthly. And finally, the redemption value of the bond. The bond has a $10,000 face value and it's redeemable at 105. Redeemable at 105 essentially means that if the face value of the bond is $100, the investor would receive $105 at redemption. So what we want to do is take the face value $10,000, multiply it by 1.05, and the redemption value is then $10,500. Substituting all these known values into the purchase price formula, you'll see that the purchase price is $9,598.52. So what this means is we'd be willing to pay $9,598.52 in order to yield a rate of J12 equals 15% on our investment. Notice that I used the alternative purchase price formula in my calculation. We could have also used the original purchase price formula that we derived, and this would have obviously resulted in the same purchase price. When you purchase a bond, if the purchase price of the bond is greater than the redemption value of the bond, then the bond is said to be purchased at a premium. The premium amount then is just the difference between the purchase price and the redemption value. If we use the alternative purchase price formula, that means that we can calculate the premium amount by evaluating FR, the coupon payments, minus CI times the discount factor for end payments that yield rate I. So what this means is at the time of redemption, you incur a loss. So for example, you purchase a bond for $11,000, but the redemption value is only $10,000. You would lose $1,000 on your investment. If the investor wishes, this quote-unquote loss they could apply at redemption to their taxes, or they could spread this loss throughout the coupon payments over the term of the bond, which would result in less tax being paid at each coupon payment period. This process decreases the value of the bond from the purchase price to the redemption value on the redemption date, and it's referred to as writing down a bond. We also have what's called purchasing a bond at a discount, and that's when the purchase price of the bond is less than the redemption value. Again, it's just the difference between the redemption value and the purchase price. And using the alternative purchase price formula, you can find a formula for the discount amount. So what this means is at the time of redemption, the investor actually incurs a gain. So, for example, the redemption value of a bond is $10,000, but they only purchased it for $9,000. So that means at the time of redemption, they'd gain $1,000 in which they'd have to pay tax on. Instead of paying that tax all at once, they could again spread this gain over each bond interest period. This would result in more tax each period, but at the time of redemption then, they would not have to pay as much tax. So in this case, we're increasing the value of the bond from the purchase price P to the redemption value C at the redemption date, referred to as writing up a bond. Suppose we had a 10-year $15,000 bond and it's redeemable at par, pays quarterly coupons at J4 equals 8%, and is priced to yield a rate at J4 equals 6%. Determine the premium or discount amount of the bond. So here we have a $15,000 bond that's redeemable at par, which means the face value and the redemption value are both $15,000. Also, the bond pays quarterly coupons at J4 equals 8%, which means the coupon rate R is 2% per period. The investor wishes to yield only J4 equals 6%, so I equals 0.06 divided by 4, or 1.5% per period. Since the yield rate is less than the coupon rate, the investor would be willing to pay more for the bond, which means they would be willing to purchase it at a premium. And the premium amount that the investor would be willing to pay is FR minus CI times the discount factor, which results in $2,243.69. So using this amount, we could easily now calculate the purchase price of the bond. The purchase price would then just be the redemption value of $15,000 plus this premium amount, which would give us $17,243.69. Recall from the previous slides that if you purchase a bond at a premium, that means at the time of redemption, the investor would incur a loss. They can spread this loss out over each of the coupon periods in order to pay less tax at each period. This is referred to as writing down a bond. Similarly, If we purchase a bond at a discount, it means the investor incurs a gain at the time of redemption, and they can spread this amount over each of the coupon periods in order to pay a little more tax at each coupon period, but less tax at the time of redemption. From the previous example, we already determined that the bond was purchased at a premium. So here we're going to take a look at a bond schedule for when we're writing down a bond. So when we create a bond schedule, there are a number of things to consider. The period, K, the coupon payments, which are F times R, the interest on the book value, which is the yield rate, I, times BK minus 1, where BK minus 1 is the previous book value on the bond. The book value adjustment, which is the difference between the coupon payment and the interest on the book value, and then the book value itself, which is the previous book value of the bond minus the book value adjustment. So in this example, at time 0, the book value of the bond is actually the purchase price, which is the redemption value of $15,000 plus the premium amount paid, so $17,243.69. Then, after one coupon payment of $300 is made, the interest on the book value is I times the purchase price, which gives us $258.66. The book value adjustment then is the difference between the coupon payment and the interest on the book value, which gives us $41.34. So to find the book value of the bond at this point in time, it's just the difference between the purchase price of the bond and the book value adjustment, which gives us $17,202.35. And this is essentially the value of the bond after the first payment has been made. And we can continue on through the bond schedule. Let's take a look at the time when the 19th coupon is paid. So the coupon payment always remains the same at $300. We aren't going to worry about the interest on the book value or the book value adjustment after the 19th coupon payment. Let's just take a look at calculating the book value itself. Since we're writing down a bond here, the value of the bond is actually just how much you'd be willing to pay for the bond, knowing how many payments are yet to come. So in this case, since 19 coupons have already been paid out, there's 21 coupons remaining, because it was a 10-year bond and the coupons were paid quarterly. So now we can just calculate the purchase price as if there are 21 coupons yet to be paid, and you get $16,342.51. Now using this information, we can calculate the line after the 20th coupon payment is made. And again, the interest on the book value is just I times the previous book value of $16,342.51, which gives us $245.14. The book value adjustment is the difference between the coupon payment and the interest on the book value, and then the book value itself is the previous book value minus the book value adjustment. In the end, by the time the 40th coupon or the final coupon payment is made, the value of the bond should just be $15,000, the redemption value of the bond. If we add up the totals in the coupon column and the interest on the book value and the book value adjustment, what you will see is that the total amount of coupons paid is $12,000. The interest on the book value is $9,756.31, and the book value adjustment is $2,243.69. So the book value adjustment actually adds up to the premium amount that we paid on the bond. If you subtract this from the total amount of coupons paid, what you'll get is the interest on the book value of $9,756.31. And this is the amount that the investor would have to pay tax on. Instead, what they could do, though, is spread this so-called loss out over each of the coupon payments so that they could pay less tax on the coupons that they've received. During next week's lab, we'll continue on with bonds and calculating the price of a bond between interest dates and taking a look at calculating the yield rate of a bond.